Okay, welcome back to Mr. Hassan's Math channel. I'm now answering question number 6 from the International A-Levels Core Mathematics C12 January 2015 paper from Edexcel. This question is related to a P2 topic now in the new specification, which is about logarithms, which is one of those alien type of topics that many students have great problems with understanding, okay, and how to apply the rules of it. Many times they just apply the rules without understanding what they're based upon, and therefore they do really things that don't make sense. So I'm going to try to make this video a bit more of kind of like a tutorial type of video about logarithms. So I might start off by just giving some basic, concepts, which hopefully will help you understand in the basis behind this and some of the laws of logarithms that we're going to be using. So here they've told us that given that 2 times the log to the base 4 of 2x plus 3 equals 1 plus log to the base 4 of x plus log to the base 4 of 2x minus 1, x is greater than a half, we got to show that this leads to the equation 4x squared minus 16x minus 9 equals 0. All right, now, first of all, what is a logarithm? A logarithm is like the inverse of the exponent function. Okay, the inverse of the exponent function. For example, if you have x plus 3, okay, the inverse of addition is subtraction. Okay, so for example, if I was to take this function x plus 3, supposing I took something like the number, say 5, and I put it inside this function, the output would be 8. Now, how do this is going this way. What do I have to do, all right, to get the 8 to become back to a 5? I have to do the inverse. The inverse operation is taking x and subtracting 3. Okay, so the inverse, if I start with 8, put it into here, I'm going to end up with 5, what I started with. Okay, so this is the inverse. Subtraction is the inverse of addition. Okay, and similarly, if I start off with x minus 4, for example, and I start off with the number, say, 11. If I put this into this function, what comes out is 7. How do I undo this function? What's the inverse of this function? What undoes this function? Well, if I put 7 into the function x plus 4, that's going to give me 11. So addition is the inverse of subtraction. So addition and subtraction, the inverses are the opposites of each other, right? Same with multiplication. If I take the number 3 and I put it in the function, for example, 2 times x, I come out with 6. How do I go from 6 back to that? All right, or for any number back to that, I have to take that number and I have to divide. So if I take the number and put it into the function 6 divided by 2, multiplying by 2, the inverse of it is dividing by 2. That's going to give me 6 divided by 2, which is 3. That will work with any number. So for example, if I start with 12, 2 times 12 is 24, put that into the inverse function, 24 divided by 2 is going to give me 12 again. So this is like the inverse. This is like the main function, and this is like the inverse. That's what undoes it. And the same, for example, if I start with, the same with division, the inverse of division is multiplication, okay? The thing like, for example, taking the square root. For example, if I start with the number 4 and I square the number 4, okay, that's going to give me 16. How do I get back to the original? I have to take the square root of that number. Okay, but there's a little side point to that. I'm only thinking the positive square root. But anyway, so that's for squaring. Now, how about the inverse of, for example, having something like, say, 3 to the power of x? 3 to the power of x. The inverse of something that's in the exponent. So, for example, if I put the number 2 into this function, what comes out is 9. How does the 9 come back to the 2? Well, that's where we have the log function. The log to the base 3, okay, of 9 is what's going to give us 2. So the log function is something which is existing to be the inverse of when you have the input in the power. Okay, so 3 to the power of 2 is 9. So log to the base 3 of 9 is 2. Okay, so you have to put 9 into this function to give you back that 2 again. All right, so the log function is basically the inverse of the exponent function. That's what it is. All right, that's why it exists. Okay, so that's a little introduction to why you have the log function. The log function is the inverse of the exponent function. All right, so 2 goes into 3 to the power of x, gives you 9. How does that 9 become 2 again? Well, we put it into log to the base 3 of 9. That gives us 2. This means 3 to the power of 2 is equal to 9. Okay, so that's a little bit of an introduction into what logarithms are there for. They're there they exist to be the inverse of the exponent function. So we can convert between logarithms and exponents quite easily. So for example, if I know that, say, as I'll just take the example, 3 to the power of 2 is equal to 9. Okay, I can rewrite this in terms of logarithms, that the log to the base 3 of 9 equals 2. So this is the base, and this is like the power, the exponent, the index, and this is the answer. Right? In terms of converting between index form and log form, this is how the format is in terms of log form. 3, this is the base, this is the power, this is the result. 3 to the power of 2 equals 9 can be written log form. Log to the base 3 of 9 gives you 2. That is the power you need to raise this by to give you 9 as your answer. Okay, so that's what we can understand from that. So let me just write that down in a more kind of general way. So if we have, for example, a to the power of b equals c, we can rewrite that as log to the base a, this is the base, of c equals, log to the base a of c equals b. That's the power you have to raise this by to give you that result. All right, that's how you can rewrite this. This is the power, this is the base, this is the power, this is the result. Okay, so a to the power of b equals c. That's how you can rewrite them. We must know how to express something from index form into log form, and vice versa, how to go back as well, how to write this in index form. Many times you have to do that in log questions. Okay, so that's one point. That's very important. Okay, the other points are you have the addition law. Okay, so for example, if I have log to the base a of b plus log to the base a of c, I can rewrite this as log to the base a of b times c. Okay, that's one of the laws of logarithms. It's just kind of like, for example, if you have, say, a to the power of b times a to the power of c, you get a to the power of b plus c, just like we know from index form. When we multiply two numbers in index form, we add the powers. It's kind of based upon that, right? It's based upon that, all right? This is like, this multiplication of b times c leads to this addition. All right, so as long as they have the same base, just like here, as long as they have the same base, you can add the powers. As long as you have the same base, you can multiply these two numbers together. So again, you can go both ways. You can split this up if you need to. You can combine it together if you need to, depending on what you need to do in the question that you're answering. Okay, now, the other law is very similar to this. Log to the base a of b minus log to the base a of c is equal to log to the base a of b divided by c. And again, it's very, very similar to the law of logarithms, where a to the power of b divided by a to the power of c can be rewritten as long as you have the same base, a to the power of b minus c. When you divide two numbers in index form with the same base, you subtract the powers. Okay, so that's, again, similar to this. It's based upon this. Okay, it's based upon this. So that's the addition law, the subtraction law, sometimes it's called the multiplication law, the division law. And then we have the third law, which is really important, which is called the power law. Okay, so, and the power law states, for example, log to the base a of b to the power of c is the same as c times log to the base a of b. That number, that power there can be written as a multiple of this. Okay, so you can rewrite this in this form. And that's very important. We'll only be using that a lot. And what's the basis behind this? Well, let's say we had log to the base a of 2 to the power of 3. Okay, well, it's only the 2. This only works when this is not the whole thing to the power of c. It's only this number to the power of 3. Okay, just this number. Okay, what this can be rewritten as is log to the base a of 2, okay, times 2 times 2, right? And using the law we just learned here, with the addition law, you could say, this can be rewritten as log to the base a of 2 plus log to the base a of 2 plus log to the base a of 2, which is, how many of them are there? There are 3 log to the base a of 2. So you can see that 3 has gone in front when you finally. So if this was a 4 or a 5 or a 6, whatever, if there was a 10, you'd have 10 of these added together, which would have given you 10 log to the base a of 2. So that's where this law comes from. Okay, so this law here is very important as well. These 3 laws are the main laws of logarithms that we're going to be using in all log questions. And if you know how to apply them, okay, even if you don't understand where they come from, if you know how to apply them, then you'll be able to answer any log questions you need to answer. Okay, so now I'm going to just get rid of all of this, and we will now answer the question. So it's just a little bit of a background into some of the laws of logarithms and what logarithms are there for, and some of the basic laws of logarithms that we use to manipulate logarithms. And now hopefully we have the foundation to answer the question. Okay, so as I stated many times with my videos, some students, they do comment that, oh, so why don't you just go to the answer? Okay, the point of making these videos is not to be a mark scheme. If you want to see the answers, go to the mark scheme. And the point of making these videos is to help students who maybe didn't get the explanations that might have helped them to understand. Maybe they didn't have teachers, maybe they're homeschooled, for whatever reason, just to help students maybe to understand things in a better way if needed. That's the whole point of these videos. Anyway, let's go on to answer the question now. So we got to show that this log equation can be rewritten in this form, getting rid of the logs. Okay, so what I'm going to do first is I'm going to simplify both sides in terms of the logarithms. So this side, I'm going to rewrite this using the law of logarithms, where, as we mentioned, if I have log to the base a of b to the power of c, I can write that as c times log to the base a of b. So I'm going to use the power law the other way around. I'm going to go this way. I'm going to rewrite this so it says log to the base 4 of 2x plus 3 squared. So I'm going to use the power law to write this in that form. And on this side, I'm going to combine these two together. So I'll have 1 plus, now this is like using the law, log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. So I'm going to write these two together as a product. So log to the base 4 of x times 2x minus 1. Okay, so that's what I've done here. I've multiplied these two together. All right, now what I'm going to do is I'm going to bring the log terms to one side. So this is log to the base 4 of 2x plus 3 squared minus log to the base 4 of x times 2x minus 1 equals 1. Right? Now, I can use the laws of logarithms to combine these two together. As I mentioned before, that even when I combine these together, they have to have the same base. These have the same base as well. So I can combine them together as one logarithm using the division law, where I have log to the base ab minus log to the base a of c can be written as log to the base a of b divided by c. So I can write this, because there's a subtraction between them, as log to the base 4 of, I have 2x plus 3 squared divided by x times 2x minus 1 equals 1. All right? So now we are almost there. All right? Now, if that 2 was written here, supposing I hadn't already written that as a power, then I couldn't have proceeded to write this, put this into this form. I have to write this as a power first, get rid of the multiple first, write it as a power, then I can combine them by the subtraction or the addition laws. Okay, so now let's move ahead. Now I can use the classical definition of a logarithm, that if I have log to the base of a equals b, log to the base a of c equals b, I can rewrite that as this is the power, this is the base, this is the power, and this is the result. So I can rewrite this as a to the power of b equals c. So I can get rid of the logarithm from this equation by rewriting this as 4 to the power of 1 equals, and this is the result, 2x plus 3 squared over x times 2x minus 1. So now I have got rid of the logarithm, and I have got something now which hopefully will simplify to give me this when I manipulate it. So for now I can multiply both sides by x times 2x minus 1, so I end up with 4 times x 2x minus 1 equals 2x plus 3 squared. Now when you have a question where it says show that, you have to put your steps very carefully and clearly. All right, you don't just write the answer down. Okay, you have to show the steps very clearly here. So I'm going to now multiply this out. This is going to give me 8x squared minus 4x. And here, when I expand this, don't forget that you don't just say 4x squared plus 9. For example, you're going to have a middle term. All right, so either you write it out in full, 2x plus 3 times 2x plus 3, and then you expand 4x squared plus 6x plus another 6x plus 9, or you can use the pattern, you square the first term, that gives you 4x squared. Don't forget the 2 is also squared. And then the middle term is going to be the product of these two, and it's a squared bracket, the product of these two doubled. That's going to be 6x doubled, which is 12x, and then you square the last term, that gives you plus 9. So now we can see if we rearrange this to bring everything on one side, as we have to show here, as equals 0. So I have 8x squared minus 4x squared, which is 4x squared. I have minus 4x minus 12x, which is minus 16x. And I have a minus 9 equals 0. And that's as required. That's exactly what we had to show. All right, so there's part A of this question. All right, there's part A of this question. Using the laws of logarithm, we use all three laws, the power law, we use the subtraction law, we use the addition law, and we use the definition of logarithms to rewrite this into this form. Okay, I hope that was clear. Now for part B, we have to actually go on to solve this equation. Okay, we have to hence solve this equation. Now this is the same equation that we started off with, exactly the same, and we showed how it became this. So that's like the first step. Now we have to go on to solve this. So for us to solve this, what I have to do is I have to try to factorize this expression. Okay, now to factorize this expression, okay, let's see if we can factorize this. Well, in factorize, you got to have two numbers that multiply to give you 4x squared, and when you two numbers that multiply to give you minus 36 x squared. What am I doing here? This is going to have 4x squared here and minus 9 here. So two numbers multiply to give you minus 36x squared. So the product is negative 36x squared, and the sum of the two numbers is negative 16. 18 and 2? 18 times 2, yes. Okay, in fact, I'm thinking this might even be a proper squared bracket. If I put a 2x here, and if I put, no, it's not a squared bracket, it can't be, because that's a negative 19. Okay, it's a negative 9, sorry. It's not a squared, that'd have to be a plus here for it to be a squared bracket. So yeah, so I'm thinking of the numbers 18 and 2. They multiply to give me 36, and they add to give me minus 16 with the different signs. So it's going to be negative 18x and plus 2x. Okay, so here the common factor of these two terms is 2x. 2x times 2x gives me 2x squared. 2x times plus 1 gives me 2x. And 2x times minus 9 gives me minus 18x. Yep, so we're left with 2x plus 1 times 2x minus 9 equals 0. There's different ways of factorizing. You could split the middle term. You could solve this by using the quadratic formula. In the end, you'll end up with 2x plus 1 equals 0. So you end up with x equals negative a half, and 2x minus 9 equals 0. So x equals 9 over 2. Okay, so now very clearly it tells us x is greater than a half. So we're not going to accept this. Even if they didn't tell us this, we should know this, because any value of x which causes any of the log terms to become negative will cause this to be undefined. Okay, it will cause this to be undefined. So for example, if I substitute in here a value of x which makes this a negative, any of these parts negative, then it won't be acceptable. In this case, if I put minus a half here, that gives me 3 minus 1, which is fine. But if I put negative a half here, that becomes negative. So the whole equation will be undefined. If I put negative a half here, again, it's going to become negative, so it'll be undefined, right? So we know that x equals negative a half will not cause this equation to be defined, so we have to reject the answer. So we only choose x equals 9/2. All right, so that is the answer to the question x equals 9/2. Okay, x equals 4.5. That will cause this will be positive, this will be positive, this will be positive. And if you want to make sure that you have made the right choice in your answer, if you want to make sure you haven't made a silly mistake, you can actually just put this straight into here. You can see what this gives you on that side. So you can put 2, and then we have log to the base 4, and you're going to have inside here, you'll have 2 times 4.5. So you have 2 times 4.5, okay, plus 3. All right, now what does that give us? That gives us 3.584. I'm going to store this as A. Okay, so the whole of this side should give us 3.584. Okay, let's see if it does. So the whole of the other side is going to be 1 plus log to the base 4 of 4.5, 9/2. Okay, and then we have plus log to the base 4 of 2 times 4.5, which is 9 minus 1, which is going to be 8. Oops, what am I doing there? So 8 in there. That should give us exactly the same answer, and it does. So when I put 4.5 as x in here, it gives me the same answer as putting 4.5 as x in here, and we get the right solution. Okay, and if we try to put negative a half, it's going to cause this to be undefined. All right, so negative numbers, you cannot put a negative number inside the log function. All right, so now that's basically, and that's the reason. The reason for that is because, for example, 4 to the power of x is always going to be greater than 0, never be negative. Okay, so the same applies to the inverse. Okay, so there we have the answer to part B of question number 6, and that's it. Okay, so it's just simply just factorizing what we got before and solving the equation, or you could use a quadratic formula, you could use completing the square. Any method of solving quadratic equations is fine. Don't just write the answers down, okay? That will cause you to lose marks, the method marks. So you must show that you factorized it. Now, a lot of students don't like factorizing, all right? And let me just show you some of the things that the examiners note. For example, some people, they go to the calculator, use the calculator function in the button, put A is 4, B is minus 16, C is negative 9, right? And they get the answer out as x equals negative a half and x equals 9/2. So what they do is, they want to show the examiner that they actually did factorize, or they want to, make out that they factorized. So they'll say, okay, x equals negative a half and x equals 9/2. And they'll kind of say, okay, that means x plus a half equals 0 and x minus 9/2 equals 0. Now, when you write something like that, and they might write this as the answers. They might say, okay, this is how you factorize. When you write something like that, it makes it very clear to the examiner that you did not factorize, okay? That you just worked backwards. So if you're going to work backwards, supposing you did get a brain freeze and you didn't know how to factorize it, just went blank, whatever, and you use your calculator, these are the answers, and that you're going to reject this one and choose this one, but you want to show some steps to show that you did factorize, then just think about doing it this way. You can multiply both sides by 2. That gives you 2x equals minus 1. That's how you'd work backwards, because how did you get x equals minus a half? We took this, we subtracted 1 from both sides, divided by 2. So do the opposite. So think about what happened before this step. Both sides were divided by 2, same here. So this must have been 2x equals 9. And before this step, this was 2x plus 1 equals 0, and this was 2x minus 9 equals 0. And then you can say before that, it was 2x plus 1 times 2x minus 9 equals 0. and you've kind of like worked backwards, but it looks like you've actually factorized and done it properly. So if you're going to use your calculator and you do get a brain freeze, at least show your steps in a way that makes it look like you factorized. Don't make it plainly obvious that you didn't factorize. When you write x minus a half or x plus a half times x minus 9/2, it's plainly obvious to the examiner that you did not factorize and you used the calculator to get these answers, and you're trying to show that you factorized, but not very well. Okay, so that's a little side point there. Of course, you should be confident in factorizing, but that's just in case, a little, tip there. All right, so there we have the answer to question number 6. As I said, I apologize for taking so long and answering this question, but I wanted to lay down the foundations for this topic, which many students see as an alien topic. They don't really understand the rules behind it, and they don't know how to apply them. They do some really strange things when they're dealing with logarithms. So that's why I wanted to explain it in a bit more detail. Thank you for watching. Other questions from this paper, if I do get to answer them, request me to answer them, will be found in the playlist over here in this area. Other questions from logarithms of P2 can be found in the playlist over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.